Hello everyone, how are we doing today? So we have a very nice problem for you, and so let us start the problem immediately. So Adam is rolling a fair 10-sided die. So the die is fair and it has 10 sides to it, obviously 1 to 10, and he gets to roll repeatedly. He can roll as many times as he wants and may decide when to stop at any time. So he also gets to decide when he should stop. If he obtains a value that is not 10 on each roll, if he obtains a value which is not 10, so if he gets something 1, 2, 3, 4, 5, 6, 7, 8, 9, then he adds the up phase to his total monetary sum. Okay, so if he rolls 1 to 9, then suppose he rolls 6, so he gets 6 rupees. Next time he rolls 5, so he gets 5 more, so he gets 11 rupees. Next time he rolls 3, so he get total 14 rupees. Next time he roll 9, he get 23 rupees, and so on and so forth. Okay, so that's a good deal. If he rolls at 10, he loses all of his money. Okay, so he is at 23 and now he rolls a 10 and he is at 0 and that's it, it's over. Okay, so he plays optimally, then he should stop. If he plays optimally, he should stop once he has these many dollars. So when should he stop? Okay, so I don't know about you guys. I would roll it first time, and if I get $2, I might stop. I don't want to risk my $2, right? $2 is $2, right? And so suppose I take a risk and roll again. So if I get 9, then I have $11. Payout is $11, right? So $11 is better than $2. So, but I have a 9 out of 10 chance of adding to the tally, right? So what should I do? When should I stop? Should I be greedy and should never stop until I get a 0? Obviously not. And should I stop in the first chance because I'm getting something? So if he's playing optimally logically, so we have to figure out the expected value of return. Okay, so suppose he has been playing and he has $20 now. Okay, and now he decides to roll, he is not stopping. Okay, so what will happen? So there is a 1/10 chance he'll get 1, 1/10 chance he'll get 2, 1/10 chance he'll get 3, and so on and so forth, and we'll worry about the 10 later part. Okay, so he is expected to get, so this is 9 into 10 by 2, which is 1 by 10 into 9 into 10 by 2, which is 45, plus there is a 1 by 10 chance he does not get anything, furthermore he lose everything, minus 20. Okay, so if he rolls, if he decides to roll at 20, he is expected to make 25 by $10. Okay, so that's what he is expected to make. If he rolls at 25, he is expected to make 45 by 10, or expected to lose all the things. So he's expected to make 20 by 10, $2 at 25, right? So if he rolls at 45, then his expected gains, so this is expected gains, this is the total expected gain. So this becomes, at 45, this becomes 0. Okay, so your expected gains are becoming 0 at 45. You don't expect to gain anything more because your potential losses and potential gains are equal. So if you roll at $2, which makes sense, you are expected to gain 45 and expected to lose $2. So that's a good deal. So 43 by 10. So you expected to gain $4 is not a bad deal. But if you roll at $45, if you already made $45, you should not get anything. So so the best way is, so once he has $45, k equals to 45. He should stop playing because then he is not expected to win anything. Okay, because at $20 he is expected to win some, but not at $45. So we should probably check this with code. So let's roll the dice and let's stop him at $5 and $10 and 15 and 20 and 25 and every at the 5 interval and see how he's doing. Okay, so if I stop him after winning $5, I make more than $5, right? Because the first roll is there is a good chance it is more than $5. So if I stop at $10, I expect to make 9.86 because there will be times when I actually make zero. So if I stop at 15, my expected is 12.14. So I'm doing this 10,000 times, 100,000 times for each of the decisions. So I will stop at 45, I will stop at 20. So as you can see, if I decide to stop at 15, 20, 25, my expected returns are increasing. Obviously, it's not 25 for obvious reasons because will be times when I get zero, but it is increasing and it keeps on increasing. So at 30 I reach 16 and 2/3, and 35 I reach 17 and a quarter, and 40 I reach 17 and 60 paisa, and at 45 I'm getting 67 paisa 70. And then as we predicted or expected, if we play multiple times, our expected return is loss. So if we are following the strategy of stopping at 45, or expected value is not 45, it is actually $17 and 2/3 dollars, 17 and 2/3 dollars. Okay, which makes sense because if you are stopping at 45, that does not mean you are expected to get 45, but you are expected to get the most, and the most amount of money you can make in this game is 17 and $2.5, because then your payout keep on decreasing, and if you stop at $100, your payout is actually equal to the $10. So that's not bad if you play 100,000 times. So I would play for $100, or maybe I should stop at 45. So as you can see, the payout increases if you put the stopper later and later, but as you cross 45, your payout start to decrease. So this is a nice little program which confirms what we got from our theory, and also gives us the average payout which we might receive, and it is 17 and 2/3. So it will be nice little problem, maybe computation heavy, to actually figure out how much you are expected to get if you stop at 45, right? So that's also a nice little problem. But yes, so if you stop at $5, you're expected to get $6.50, and the maximum amount of money you get is when you stop at $17, if $45, and the amount is 17 and 2/3 of a dollar. So it confirms and also gives us more insight into the problem. So nice little problem with a nice little payout graph, and I do hope you enjoyed it. I enjoyed it quite a lot. So keep learning, keep being awesome. Thank you. Bye.